Welcome back. Today we're going to be finishing up Unit 3 by talking about ordering rational numbers, and we're going to be doing it with more ways than just benchmarking. Let's go ahead and get started right now. So here we've got some key ideas. Remember, it's not always possible to use benchmarking to order numbers. Sometimes we need to convert all the numbers into one form. And the best way to convert all numbers to is decimals. Remember that the only way to get from fractions to percents is a decimal. So since you have to go through the decimals no matter which way you're going, decimals is the common number type that we are going to use. Remember that when we're talking about least to greatest, we mean smallest to biggest or smallest to largest. And when we're talking about greatest to least, that means we're going largest to smallest. So let's take a look at our first example. So here we are at example A, and it says order these students' quizzes from greatest to least. So I've got Ethan's got a 19 out of 20, Jeanette's got a 96%, Rose has a 23 out of 25, and Matthew has an 11 out of 12. So we've got a whole bunch of different scores and what they mean. And we're going to be putting them in order from greatest to least. So we want the top score at the top and the smallest score down at the bottom. So we're going to have to turn these all into one type of thing because they're very close. All of them are very close to being perfect scores. 19 out of 20, just one away. 96% is very close. 23 out of 25 is very close. 11 out of 12 is very close. So we're going to have to turn all of these into decimals in order to figure out which is which. Now, again, the only way to turn fractions into decimals is to use long division. But remember that we have that trick that if we can get it out to 100, then we can tell where it is in the hundredths place. So let's do that for our first number. So first number I got out of 20, so I can multiply that by 5 because that will give me to 100. So if I multiply 20 times 5, I can do 19 times 5, and 19 times 5 is 95. So I've got 95 out of 100. So I know that's 95 in the hundredths place. That's going to give me 0.95. So that's my first decimal. The next number I have is a percentage. So again, I know I've got my decimal point here at the end, and I just need to move 2 places to the left, or I need to multiply by or divide by 100. Since I'm going to just be moving my decimal point, I'm going to be doing that, and I've got 0.96. So already I was able to tell the difference between these two numbers and notice that the 0.96 is greater than the 0.95. Let's go to the 23 out of 25. So again, I can do that trick where I multiply out to 100. So 25 times 4 is going to give me 100. And then I can do 23 times 4, which is 92. So then I've got 92 hundredths, or 0.92, or 92 in the hundredths place. So then I'm down to 11 out of 12. And I know 11 out of 12 does not go into 100 easily. So there's nothing I can multiply 12 by to get 100. So unfortunately, I'm stuck doing long division for that problem, but it is the only one I have to do long division for. So it could be much worse than it's going to turn out to be. So let's go ahead and do that now. We're going to be doing 12 divided by 11. So I'm going to put the work up here so I've got plenty of space to work beneath me. 12 does not go into 11 evenly. So I'm going to have to place my decimal point, and I'm going to have to throw up a 0 there. And then I'm going to have to figure out what number 12 goes into 110. So 12 goes into 110 9 times. So 9 times 12 is 108. So that leaves me with 2 left over. Again, 12 doesn't go into 2. So I'm going to go ahead and bring down my 0. 12 goes into 21 times, so 1 times 12 is 12. 20 minus 12 is 8. 12 doesn't go into 8 evenly, so I'm going to have to throw another 0 there. 12 goes into 86 times, so 12 times 6 is 72, which is going to give me 8 again, and then bring down my 0, and then I'm going to have to throw another 6 again, and it looks like it's going to be repeating from here on forward. So I know that my decimal is going to be around 0.91 with the 6 repeating. So now that I've got everything as a decimal, I can much more easily put them in order. So let's take a look at the one that's the least. So I'm looking at all of my numbers here and their place value, and I know that they're all in the 90s, but I've got a 1, a 2, a 5, and a 6. So the 1 is going to be the smallest one out of those. So the 11 out of 12 is the one that's going to be the least. And again, even though I turned it to a decimal, I'm going to be writing it in the original form, the form that I was given. I wasn't given 0.916 repeating. I was given 11 out of 12. So when I have to write my answer, I have to write it in the original form. So 11 out of 12. The next one is going to be the 92. So that's going to be Rose. And again, I'm going to write that as 23 out of 25 because again, I'm going to write it in the original form that I was given. The next number I have is 95, so 19 out of 20, again, writing it in the form that I was given, and finally the 96%. So now I've got them in order from greatest to least, again, in the original forms that they were all given. So let's go ahead and take a look at the next one. So here we are at example B, and it says order these numbers from least to greatest. So we're going to go smallest to biggest this time. Now I've got 1/3, 0.3, 3.4%, and 3/8. So again, I can't really do a lot of benchmarking here. I might be able to do some, but I've got 1/3 and 0.3. I think those are pretty close. 3/8 seems pretty close to all of that. 3.4% maybe. So we're going to have to turn them all into decimals because there's not a whole lot of benchmarking I can do here. Hopefully I know that 1/3 is 0.3 repeating. That's one of those ones that we need to have memorized because it's a common conversion, and if we go to do it in long division, we're just going to end up with getting 3 and 3 and 3 and 3 again. We'll just end up doing it over and over again, and we don't want to have that situation. So to avoid it, I want to just remember that 1/3 is 0.3 repeating. The 0.3 is already a decimal. I don't need to do anything to that, so that's super fantastic. Now I need to move my decimal. Now granted, it is a percent, but my percent has a decimal in it. It is not a decimal alone. I have to move the decimal point. Just because it's a percent with a decimal in it does not mean it's been converted to decimal form. So I'm going to be moving my decimal 2 places to the left, 1, 2, or I could be dividing by 100. Either way, I'm going to do the trick to move my decimal 2 places to the left, and I'm going to end up with 0.034. So now I'm down to 3/8, and this may be one that we have memorized. It may be one of those common conversions that you picked up. Eighths is a very common conversion that we're going to be doing, but if you've forgotten, then we're going to need to be going with long division, which isn't that bad. Out of the 4 numbers, we only need to do 1 long division problem, so let's go ahead and do that now. I don't know 8 goes into 3. 8 does not go into 3, so I'm going to put a 0. I'm going to put my decimal point. I know it goes into 30, though. 8 goes into 30 3 times, which gives me 24. 30 minus 24 is 6. I know that 8 doesn't go into 6, so I'm going to need to bring down a 0. But 8 does go into 60, 7 times, 56. Bring down my 4. Then it goes in there 5 times to 40, and I end up with 0. So I've got 0.375 for my 3/8. So now that I have everything converted into decimals, I can figure out which one has the least amount of value. So looking at all of my numbers, I'm going to take a look at their first place value. So for 1/3, I've got a 3 in the 10th place. I've got a 3 in the 10th place for 0.3. I've got a 0 in the 10th place for 3.47%. And I've got a 3 in the 10th place for 0.375. Since I know that 0 is going to be smaller than all of the other 3s, I know that my 3.4% is going to be the one that has the least amount of value. And again, I'm going to write it in original form. I don't want to write it in a form that I would turned it into. I want to write it in the original form. So now I need to go to the next value that I'm looking at. So I've got a 3 here in my hundredths place. I'd have a 0 here in my hundredths place for my 0.30. I've already done 0.034, so I don't need to do anything with that. And I've got a 7 in my 10th place here. So again, my 0 is going to be the smallest number there, so I know 0.3 is going to be the next number up that we're doing. And then we're going to go to our last digit that we have, our last place value. I've got a 3 for the 0.3 repeating, and I've got a 5 for 3/8. So the 5 is going to be greater than that 3. So I know that 1/3 is going to come next, and then finally 3/8. So make sure that your paper looks like mine, and let's move on to the next one. Here we are at example C. It says order these numbers from greatest to least. So I've got 11/2, 5.5%, 11/20, and 5.05. So good news, there's a large range of numbers here, so we might be able to use some benchmarking and save ourselves some time. So just looking at my numbers, I know that I've got 11/2, so that's going to be way more than 1. 5.5% is a really small number, real small percentage. 11/20 is a little bit more than half, and 5.5 is again way more than 1. So knowing that information of putting these numbers in order from greatest to least, I can figure out which ones are the smallest ones right away. I've got the 5.5%, which is really, really small, and the 11/20 that's almost half. Both those are less than 1, and I know the 11/2 is more than 1 and the 5 is more than 1. So I know those two are going to be the smallest. So I know 5.5% is going to be way smaller than something that's almost half. So I know that that one is going to be the smallest one. So I can move that first. I don't even have to do any math. I just know that that one's going to be the least amount of value. Then I've got my 11/2. Again, that's going to be smaller than the other two numbers because the other two numbers are more than 1. So I'm going to just put that in as 11/20. And again, I didn't have to do any math there. I just used reasoning and benchmarking to determine that those things were less than 1 to save myself some time and energy. So now I'm down to 11 halves and 5.05. So I may not know which one is greater, 11 halves or 5.05. So I'm going to have to turn them both into decimals. Luckily, the 5.5 is already a decimal. So that leaves me with just going to the 11 halves. So I'm going to take the 2 on the outside. That's the denominator. The 11 on the inside. That's the numerator. 2 goes in 11 5 times. 5 times 2 is 10. That's going to give me a 1. Then I'm going to have to bring down my 0 because it doesn't fit. I'm going to have to put in a decimal point. 2 goes in a 10 5 times. So that's going to give me 2 times 5 is 10 and give me a 0. So I don't have to go any further than that. So I have 5.5 versus 5.05. And I know that if I'm looking at my place value, the 5s in the front may be the same, but I've got a 5 in the tens place and I got a 0 in the tens place. So I know that 5 is going to be greater. So then I know the biggest one is going to be 11 halves. And the next smallest one is going to end up being 5.05. So there we go. I was able to put them in order with doing only a little bit of work, only a little bit of long division. Everything else I was able to use benchmarking for, so reasoning does come in handy here. Let's take a look at example D. So here we are at example D, and it says order these numbers from least to greatest, and I've got some negatives and some positives here. So again, I can go to my benchmarking skills to understand maybe I can save myself some time and energy. Because I know automatically that the negatives are going to be smaller than the positives. So I've got 2 negatives, so let's take a look at those and compare them first, and then we'll compare our positives. So we're going to work with just our negatives first, so I'm going to isolate those by drawing some red boxes around them so that I know I'm only working with negatives, I only care about them. I've got negative 2.4 and 5%. Now I could turn them both into decimals. That would work if I'm not really sure, but I'm going to use some benchmarking skills. I know negative 2.4 is way negative. It's like owing somebody $2.40, whereas negative 5% is almost positive. So I know that one of those is going to have much less value, and that's going to be the negative 2.4. So I'm going to go ahead and drag that in. Again, you could turn that negative 5% into a decimal and figure out which one is greater or least by comparing the place value. There's nothing wrong with that, but I'm going to use some reasoning. Now I know the negative 5% is going to be smaller than the other 2 positive numbers, so that one's in there. And now I'm just down to 2/3 and 60%. So hopefully I've got 2/3 memorized because it's one of those common conversions that I should have memorized. And I know that that's going to be 0.6 repeating. If I can't think of that, I can know 1/3 is 0.3 repeating, 2/3 is 0.6 repeating. So I know that's 0.666 on and on and on forever and ever. And then I've got 60%. So now I'm going to turn my 60% to a decimal. I'm going to do that by moving my decimal point 2 places to the left. 1, 2. And I end with 0.60. So I've turned those both into decimals. So now I can compare them. The 6's in the tenths place are the same. I've got a 6 in the hundredths place, and then I've got a 0 in the hundredths place. So I know that 0 is going to be smaller than that 6. So the next one up is going to be 60%. And then finally, my largest number here is 2/3. Make sure that your paper looks like mine, and then let's move on to the next example. So example E here says I need to place the correct number in the box. So I'm looking for something that's bigger than 20% and smaller than 1/4 in my first example. And then I'm looking for something that's bigger than 0.04 and smaller than 8.5%. So the only way to do this, since I'm trying to compare numbers, is I need to have everything as a decimal. So I'm going to start with my 20%. I'm going to move that to a decimal first. So I'm going 1, 2, and I've got 0.20. And then I got 1/4. Hopefully that's one of those common ones that I have memorized, and I know that's 0.25. So now that I have those 2 into decimals, I've got a whole bunch of possible answers here on the right-hand side, so I'm going to have to turn those to decimals. But let's go down and take a look at the next one. 0.04, that's already a decimal. Don't have to do anything with that. 8.5%, I'm going to move that decimal place. Again, although it has a decimal in it, it is still a percent. You can see the percent sign, so I'm going to have to turn that into an actual decimal. I know that it is a percent with a decimal, but that does not make it a decimal. So I'm going to move my decimal point 1, 2 times, putting my decimal point, and I should have 0.085, and then 0.04 I don't need to do anything with. It's already a decimal. There's no reason to rewrite it. So now I've got to just turn everything else that I have into decimals. So 0.5 is already a decimal. Lucky me, I don't have to do anything with that. 1/20th gives us the trick where we can multiply by 100. So I'm going to go ahead and do that now. So I've got 20 gets to 100 by multiplying by 5. So let's do that times 5 on both sides. So that's going to give me 100. 100 times 5 will give me 1 times 5 is 5. So I've got 5 over 100. So 5/100ths. So I can write that decimal as 0.05 or 5/100ths. And then I have 2/9, which unfortunately, if I don't have the ninths memorized, I can figure out what they are. Now, the ninths do have a trick that is good to know when you're working. So let's go through that trick right now to be helpful. If I have 1/9, that's going to be 0.1 repeating. If I have 2/9, that's going to be 0.2 repeating. How do you know this? Well, if you have 3/9, 3/9 reduces to 1/3, and 1/3, as we know, is 0.3 repeating. So as we can see a pattern here, 1/9 is 1 repeating, 2/9 is 2 repeating, 3/9 is 3 repeating. If I have 4/9, that would be 4 repeating. So hopefully this is something that you can use to save yourself some long division. Remember, all of this is about trying to save ourselves as little long division as possible. Nobody likes long division. We're going to try and avoid it at all cost. So since I know 2/9 is going to be 0.2 repeating thanks to my little ninths trick, I'm going to know now how to figure out what belongs where. So I've got 0.20, 0.25. Well, 0.5 is going to be way bigger than 1/4, so that won't work. 0.05 is going to be way smaller than 0.02, so that won't work. Now, if I extend out my 2/9 to more than one decimal place, I would end up with 0.22. So if I've got 22 and 25 and 20, I know that one's going to be right in the middle, so I can go ahead and drag my 2/9 there. Then I've got 0.04 and 0.05. Again, now since I've eliminated the 2/9, I only have two numbers to really compare. One is 0.5, which is way bigger, and one is 1/20th. So even if I didn't do the math, even if I didn't want to make my 1/20th a number there into 0.05, I can know that 0.5 is too big and it won't fit. So I know that 1/20th is the real only choice left. So again, got to use your reasoning. You can't always just depend on math. Sometimes you have to think in order to get questions right. Let's go ahead and take a look at some practice problems. So here is practice number 1. It says, use the choices provided to fill in the missing boxes. The numbers should be arranged in order from least to greatest when you finish. So you've got two numbers there, 7/9 and 1.35. It wants you to find a number smaller than 7/9 on one side and find a number bigger than 1.35 on the right-hand side. So you've got 4 possible answers down there. Remember to use both your reasoning and your math to figure out which ones are the right answers. So go ahead and try them now. Pause the video, then press play again to see if you are right. How did you do? Were you able to get the right answer? Did you see that 150% was 1.5 and much larger than 1.35? Did you figure out 9.5% was really, really small and therefore could be easily figured out to be the smallest one out of the whole bunch? Again, you didn't have to use long division to do this or even conversions. You could have just used some reasoning. It's up to you to determine what the best way to solve each of the problems is. Let's go ahead and try a second practice problem. Here we are at practice problem number 2. It says determine if each statement is true or false and show why. So you're going to figure out which one is our true and false, which one's greater, which one's less, and you're going to circle to see which ones you figured out to be true. Or you can write true and false, up to you. They're your notes, whichever works best for you. So go ahead and pause the video now, press play again to see if you are right. How did you do? Were you able to get all of them right? Notice that I've converted everything to decimals so I could compare both the decimals together to determine which one had the least value or which one had the greatest value. Hopefully you went and got that one error that was false and the others were true. If you did, great. If not, go ahead and fix your paper that looks like mine, and let's take a look at the final example. So here we are at example F, and it says which of these values are less than point n, and luckily it gave us point n as a decimal, 1.6, fabulous. We don't have to figure out what point n is, but we are going to have to figure out what all these other points are to determine if they are less than point n. So I've got 3/2, 170%, 5/3, and 1.09. So let's start with the already decimal, which is 1.09. I can see that I've got a 0 in the tens place and a 6th in the tens place down here at 1.6, so I know that that is going to be less than n. So right away I know I've got one right answer, so I'm going to throw a box around that, and that one is right. So let's go ahead and take a look at the next easiest one, which I think is 170% because it's a lot easier to turn percentages to decimals than it is to turn fractions with our long division. So let's go ahead and drag our decimal place 2 places to the left, 1, 2. And when I do that, I end up with 1.70. Now 1.70 I would say is not less than 1.6 because the 6 is going to be less than the 7, so I know that is not a right answer. I can go ahead and cross that out as not one that is correct. So now I've got 5/3 and 3/2. So again, I got to do some long division. It might be, you may know 3/2 off the top of your head, but 5/3 probably not so much. So let's go ahead and start with 3/2. That one's going to be a little bit easier for us. So I've got 2 divided by 3. 2 goes into 3 one time. I get 2, I get 1 left. 2 doesn't go into 1, so I'm going to need a decimal point. I'm going to need a 0. 2 goes into 10 5 times. 5 times 2 is 10, which gives me a 0, so 1.5. Now, is 1.5 less than 1.6? I'd say so. 5 is less than 6. So I know I've got myself another correct answer, so I'm going to go ahead and put a box around that and a giant check, because I know that one is right. So now we're down to just our last problem, which is 5/3. So again, we're going to have to do some long division. So let's go ahead and we got our 3 as our denominator, divided into our numerator, which is 5. 3 does go into 5 one time. 1 times 3 is 3. 5 minus 3 is 2. 3 doesn't go into 2, so I'm going to have to throw my decimal point and 20. 3 does go into 20, and it goes into 26 times, because that's going to give me 18. 20 minus 18 is 2. 3 doesn't go into 2, so again, I'm going to have to throw another 0, which is going to give me 20, and I'm going to get 18 again. And I feel like we're going to end up in this same pattern. We're going to get 1.6 repeating. So since I've got 1.6 repeating, is 1.6 repeating more or less than 1.6? Because that's the question. Well, 1.6 is 1.60, and 1.6 is 0.6 repeating. So if I'm comparing the hundreds place, the 6 is going to be more than that 0, so it does not meet the criteria. It is not smaller than point n, so unfortunately it gets an X. It is not going to work in this problem. That brings us to the end of this video. So if you like this video, go ahead and throw us a thumbs up. If you love this video, throw us a sub, and we will catch you in the next one.